We're going to find the critical points for some of these homework questions. And when we're dealing with critical points, we're basically finding the x values when the derivative is equal to 0, or the x values when the derivative is undefined. Okay, so my first function is this cubic function, and over here I do have my cubic function graphed over here, and we'll compare our answers to the graph after we're finished. So step number 1, let's go ahead and find the derivative. So y prime equals to 3x squared minus 12. And then for critical points, that happens when the derivative value equals to 0. So let's go ahead and plug a 0 on the left-hand side. And on the right-hand side, let's go ahead and factor out the greatest common factor. And in this case, that's going to be a 3. So if I factor out the 3, I get x squared minus 4. And now we have a very nice difference of squares here. So x plus 2 and x minus 2. All right, so when we set this equal to 0 here, our x values would be negative 2 for that part. And for this part, I have x equals to positive 2. So those are my answers, x equals to plus or minus 2. And if I go to my graph here, here's the graph of the original function here. And our critical points are right here and here. So this is when x equals to 2, and this is when x equals to negative 2. And once again, critical points are the x values where the derivative equals to 0, or if the derivative is undefined. But in this case, we don't have any undefined points. All right, let's keep on moving along here. Okay, so now we have another interesting function here where the powers are fractions. So we'll definitely start by taking the derivative, and then we'll compare our answer to the graph after we're finished. All right, so let's find the derivative here. So y prime equals, okay, so there's a 3 here to start, so I'm going to leave the 3 alone, so 3. And then I have 4/3, so 4/3 gets soccer kicked to the front, and then x to the power of. Now, basically, what you're doing here is you're taking 4/3 and you're minusing 1. So it's kind of like the same thing as 4/3 minus 3/3, because 3/3 is 1. So that's going to be 1/3 minus 12, which is the constant. And then over here, the 1/3 gets soccer kicked to the front. So 1/3, and then I have the x. And then I have the 1/3 minus 1. So that's the same thing as 1/3 minus 3/3. Which is going to be x to the power of negative 2/3. Okay. So that 3 is not very clear, so negative 2/3 there. Okay, and then in my next line here, let's go ahead and simplify things. So there's a 3 and there's a 3 underneath there. There's a 12 and a 3 there. So let's go ahead and simplify the coefficients first. So on the very first term here, I guess I have 4x to the power of 1/3 minus 4x to the power of negative 2/3. And then let's go ahead and put a 0 here on the left-hand side, because now we're trying to find the x values where the derivative is equal to 0 or when it's undefined. Okay, so a little bit of algebra here now. So what I'm going to do here is I'm going to deal with this part of the problem here with the negative power. So if I set up my next equation here, I have 0 equals to 4x to the power 1/3 minus 4 divided by x to the power 2/3. Okay, so when we're solving for this particular equation here, what I'll do next is I'll put this over 1 here. And I'm going to go ahead and simplify this fractional expression by using the crisscross smiley face method. So when I do that, I take my denominator and I will multiply with the numerator on the opposite side. So I have 4 x to the power 1/3 times x to the power 2/3. And if I do that, I just get 4 to the power, I just get 4x here. Now, if you're multiplying, how do I get 4x? It's just basically when we multiply x to the power 1/3 and x to the power 2/3, you just add the powers there, right? So that's going to be 3/3, and that's going to be x to the power 1, which is just x. So that's how we got the x there. Okay, and after that, let's go ahead and take the next step here. So I take this 1 here, and then I crisscross and multiply with that negative 4, so I get 4x minus 4, and then I divide that by just the denominators being multiplied here. So 1 times x to the power 2/3 is x to the power of 2/3. Okay, so if I go ahead and make this equal to 0 here, I can factor out the top. So I get 4 bracket x minus 1, and I get x to the power 2/3 on the denominator there. Okay, so when is this equal to 0? Okay, well, I take a look at the numerator there, and if I take a look at that, this is going to be x equals to 1, so that will make the numerator equal to 0. And then I also look at the denominator here, right? So I have x to the power 2/3, and if I set that equal to 0, that will make my derivative undefined, right? So when I solve for this, x will also be 0 there. So we have the critical points when x equals to 0 because the slope is undefined, and I have another critical point when x equals to 1 because that's when the derivative does equal to 0. Okay, let's go to the graph here now. So what does that look like on the graph here? Okay, so at this point right here, this is when x equals to 0, and I guess the slope there is undefined because we have a vertical tangent line there. And our other answer is right here when x equals to 1, and we definitely have a horizontal tangent line like that, so our derivative is equal to 0 there. Okay, so that's what the critical points will look like on the graph there. Okay, let's keep on moving along here. Okay, so our next question here, I have y equals to the cube root of x times 2 plus x. So before we start this particular problem, let's go ahead and rewrite this as y equals to x to the power of 1/3 bracket 2 plus x. And then we're going to just distribute this into the brackets there. Okay, so y would equal to 2x to the power of 1/3 plus. Now, before we distribute the next part, one thing that could help when you're solving this problem here is you can write this as x to the power of 3/3. Remember, 3 to the power of 3/3 is the same thing as x to the power 1, right? So it's equivalent, and basically when we multiply with this and this, we're just adding the powers there, right? So we're just adding 1/3 plus 3/3, and that's going to be x to the power of 4/3. Okay, so that's just distributing that x to the power 1/3 into the brackets there. Okay, let's go ahead and take the derivative here. So y prime equals to, all right, so this 1/3, and let's multiply that with the 2, so I get 2/3 there. And then this will be x to the power of, well, it's really 1/3 minus 3/3, which is going to be equal to negative 2/3. So negative 2/3 plus, and then I have this 4/3 here. That's going to be soccer kick to the front, so 4/3. And then x to the power of, okay, well, it's 4/3 minus 1, right? So if I do a side calculation here, I have 4/3 minus 1, which is the same thing as 4/3 minus 3/3. I get x to the power of 1/3. Okay. All right, so there's my derivative there, and now I need to set this equal to 0 here. And there's a few things you could do for this particular problem here. I would just make this equal to, all right, so if I take a look at this term here, I guess we have a 2 on the numerator, and we have a 3 on the denominator there, and we can leave the x to the power 2/3 on the bottom, plus now we have a 4/3, and then we have x to the power of 1/3. Okay. So there's a few things you can do here, but I'll ultimately just do the crisscross smiley face method again. So I'll start over here with the 3, and that will crisscross and multiply with the 2. So that's going to be 6 plus. And then if I take this expression here and multiply it with that expression here, well, let's start with the 3 and the 4. So this 3 and that 4 will give me the 12. And if I multiply x to the 2/3 and x to the 1/3, that's going to be x to the power of 2/3 plus 1/3, which is really x to the power 3/3. And 3/3 is really just 1, right? And then divide that by the bottoms all multiplied. So 3 times 3 is 9, and that'll be 9x to the power of 2/3. Okay. Let's go ahead and simplify this. On the numerator here, I guess I can factor out a 6. So this will be, actually, let's just factor out a 3 here. So if I factor out a 3, I get 2 plus 4x. And then on the denominator there, I have a 9x to the 2/3. And if I keep on simplifying here, I guess this and this will cancel off. So that's gone, and this will become a 3. And then I guess from here, we can just we can take a look at the numerator here. So we can set the numerator equal to 0. So that's going to be 2 plus 4x equals to 0. 4x would equal to negative 2, and x would equal to negative 1/2. So there is one of my critical points. And then we also have the denominator, right? If I set the denominator equal to 0, 3x to the power 2/3 equals to 0, that really means that x also equals to 0. So here's my other critical point. because that is when the derivative equals to 0 there. Okay, if I go back to the original problem or the original graph here, and if we try to graph this, the results here, here is x equals to -1/2. So as you can see, there's a horizontal tangent line there. That's when the derivative equals to 0. And we also have a critical point when x equals to 0 there, because we have a vertical tangent line there because the derivative is undefined at that particular point. Okay, so that's it for that particular question, and let's go on to the next critical points problem here. Okay, so now we have this rational function here. Okay, so here's my rational function here, and one thing that I noticed is that if I take a look at the denominator there, we have vertical asymptotes when the denominator equals to 0, right? So if I go and solve for this, I get x equals to plus or minus 1. So what that really means is we have some vertical asymptotes on the graph here. So that just means the graph does not exist at x equals to 1 or positive 1. Just by looking at this, I feel like there's only one critical point, which is right here. That the maximum point right there, that looks like the critical point there. And let's go ahead and verify that it does equal to 0 there. Okay, so let's go ahead and figure this out here by taking the derivative here. So this will be y prime. Okay, so using the quotient rule, the derivative of 4 is going to be 0, so 0 times the bottom. And the quotient rule states that we need a minus sign. And then the top is going to be 4, and then the bottom is going to be 2x, all divided by bracket x squared minus 1 to the power of 2. Okay, so this part right here is going to be 0, so this will be y prime equals to, okay, so we have a negative 8x, right? So that'll be at negative 8x, all divided by x squared minus 1 to the power of 2. Okay, so basically we want to know when the derivative is equal to 0, right? So if I just change this y prime to a 0 here, the derivative is equal to 0 when the numerator equals to 0, right? So if I just solve negative 8x equals to 0, that means x would equal to 0. And we also stated that the critical points are found when the denominator is undefined, right? So if I take the bottom here and set that equal to 0, that would make the derivative undefined, right? And if I go ahead and solve this, I get x squared minus 1 equals to 0, x squared equals to 1, and then x would equal to plus or minus 1. So we're probably thinking that, hey, these are also critical points because that's when the derivative is undefined. However, when I go back to my graph here, it turns out that we have a vertical asymptote at -1 and positive 1, so those don't count as critical those don't count as critical points because the graph does not exist there. So it turns out that our only critical point is, let me just erase the vertical asymptotes there. Our only critical point is this point right here. That's when x equals to 0, and we definitely have a horizontal tangent line right there. Okay, so there's our answer for that particular problem. Okay, so the last question on this homework video guide is we need to determine whether the function has an absolute max or a minimum, a relative maximum or a minimum, or neither a maximum or minimum point for each value below, right? Okay, so let's take a look at this graph here and let's just quickly go through what each point means. I'm going to take a look at point number 2 here, and point number 2 looks like the lowest point. So this is definitely this will be definitely the absolute minimum because that's the lowest point. However, when you have an absolute min, we can also call that a relative min as well. So I'll put a relative min here as well. Alright, so once again, it's called an absolute min because it's the lowest height on the graph. And when it's a minimum, you can also call it a relative minimum as well. So relative minimum as well. This point over here, it's not really turning into a maximum or a minimum point here. So we can call that, this is the neither point here. It's neither a max or a min. If I move on to point 3 here, there's point 3. At point 3, it's a maximum, so we call that a relative max. It's a relative max because it's just a maximum, it's not the highest maximum. Okay, and then this point over here, I have a cusp right here, but we call this a relative minimum because it's a minimum, but it's definitely not the lowest. And this point over here in red, it's another maximum point here, so this is a relative max. And over here now, the next point here, I have a horizontal tangent line there. So this one's going to be a neither here. It's not a max or a min. And then over here, I'm back to having a minimum here. So this is a relative minimum there. And then one thing I see right here is the difference between this endpoint and this first endpoint is that this is the highest point, right? So we call this the absolute max. Okay, so since that point is the highest, that has to be the absolute max. If it's not the absolute max or min and you're at an endpoint, we just call that like a point that's neither a max or a min. Okay, so that's it for this first homework video guide.